Okay, so we go to the application of differential equation. This is example 10.14 from your textbook. So basically, usually when we want to solve application question of differential equation, it's easier if we can draw the situation, what happened, and then what they want, and so on. Okay, so basically, what I can conclude if you read the question, what I can conclude is that there is a beaker, and then there's hot water, and the room temperature is 18 degrees Celsius, and the water is 82 degrees Celsius, and then after 6 minutes left in that room, the water in the beaker become 50 degrees Celsius. And the question asks, what is the time taken so that for the temperature to become from 26 degrees Celsius to 20 degrees Celsius? And the question also give one more sentence, which is they said that the rate at which the body loses its temperature is proportional to the temperature of the body when it exceeds the temperature of its surrounding. So that sentence you can write in equation form like this. So they said the rate, so rate we know it's going to be dt of the temperature of the body. So I let theta be temperature of body. So the rate at which the temperature of the body, rate d theta dt, is proportional to the loses its temperature is proportional to the temperature of that body, which is theta, exceeds the temperature of its surrounding. So minus 18, because room temperature is 18. So temperature of its surrounding is 18. So if we write that in equation form, you will get this one. So the hardest part actually is coming up with this equation to solve application for the differential equation. But most of the time they will give you this equation, but sometimes they don't. So you have to come up with yourself. So we have this one, d theta over dt is proportional to negative theta minus 18. So as usual, now we can just solve this like usual. So I think you learn from your form 5, if you have a proportional sign here, if you want to convert into equal sign, d theta dt, if you want to convert into equal sign, we must put a constant. Could be k or c or whatever. Theta minus 18. I think you learned this in your form 5 from your physics. Okay, to convert a proportional sign to an equal sign, you must put a constant. Okay, next is we can solve this equation. We see that this is just a normal differential equation, and we can separate the theta from the t. So if I separate theta from t, I will bring this one, theta minus 18, to the left side. Theta minus 18 d theta equals to negative k dt. So, and then we integrate both sides. So we get like that. Okay, so if I solve this one, I can get an equation, and then I can find this one. But since they give you this condition, they said in 6 minutes, they will go from 82 to 50. And we see that in our equation, this right side represents the time, left side represents the temperature. So actually we can put this temperature and this time as the lower and upper limit. So for example, for the left part, it must be concerning with the temperature because it's all about theta, temperature of the body. So lower limit means what is the initial? Initial is 82. So lower limit is 82. Upper limit, what is the final? Final is 50. So upper limit is 50. 1 over theta minus 18 d theta equals to negative k dt. And also here we can also put upper and lower limit. Lower limit is since it starts from 0, so our limit is 0, and in 6 minutes it becomes 50, so this should be 6. Okay, then we try to solve this equation. So integrating the left part, we should get ln theta minus 18 from 50, 82 equals to, integrate negative k is just going to be negative kt, because integrate in terms of t, from 0 until 6. Then we sum in everything. We will get on the left side ln 50 minus 18 minus ln 82 minus 18 equals to, this part is going to be negative k6 minus negative k0, which is 0. Okay, so the right side is negative 6k. The left side would be, this part is ln 50 minus 18, we should get 32 minus ln 82 minus 18 is 64. So we know that ln minus is divide, so this is ln 32 over 64 equals to negative 6k, or this one is 1 over 2. Therefore, negative 6k is ln 1 over 2. And then I can bring negative 6 to the right side, become k is negative 1 over 6 ln 1 over 2. Okay, so now I have k. It's not solved yet, because what we want is we want the time taken for it to go from 26 to 20. So now what we can do is we will take our equation, this equation, this one, but our limit now we have to change. So limit should be, for the temperature, it should be from 26 to 20, and for the time it should be from 0 until t, like, or t, you want to put t or you want to put s or whatever to represent the time taken. So if I write that, it would be like this. It's going to be from 26 to 20, so 1 over theta minus 18 d theta equals to, from 0 until, let me put t to represent the time taken, 26 to 20, negative k dt. And we know, since we know that actually our k is 1 over 6 ln 1 over 2, so I can solve the right side. It should be 1 over 6 ln 1 over 2 t, from 0 until t. On the left side, we will do the same thing. This one, if you integrate, it should be ln theta minus 18 from 20 until 26. So we will do the same thing. So solve this one. It's going to be ln 20 minus 18 minus ln 26 minus 18 equals to, this part is 1 over 6 ln 1 over 2 t minus with ln 1 over 6, 0, so 0. Okay, so now what we need is, we need this t. What is the time taken? So we solve the left side. 20 minus 18 is 2 minus with ln 26. 26 minus 18 is 8. 1 over 6 ln 1 over 2t. So left side is now ln 2 over 8, which is 1 over 6 ln 1 over 2t. 2 divided by 8 is 1 over 4. So ln 1 over 4 equals to 1 over 6 ln 1 over 2t. So we want t is equals to this whole thing, ln 1 over 4 divided by 1 over 6 ln 1 over 2. So next you just press that into the calculator. Ln 1 divided by 4, ln 1 over 4 is divided by 1 over 6 divided by ln 1 over 2, 12. So you should get 12. Therefore, the answer is, the time taken is 12 minutes for the temperature to become from 20 degrees Celsius to 26 degrees Celsius. So done.